So, we're glad to have Erik with us today. His presentation is on, let me see here, the art of code churn. So I just want to say that we have a few interns in the house. Erik was actually intern with us quite a few years ago. It was probably number year or two when we were still in an innovation place. And he was with us for the summer. Then he went back to school. And after that, he started working with Noodle Cake, where he's currently a CTO. So there you go, guys. This is the progression in this field is quite fast, and it could be quite exciting. So here we go. If we could only figure out how to wear a mic. Go ahead, Erik.
Thank you, Alan. Yeah, it's true. Vendasta was a long time ago, so it's kind of nice to come and see how things have changed. Back when I was here, I think it was 11 or 12 of us. We all fit in one little conference room out at Innovation Place, and those days are long since past. So it's nice to see you guys enjoying some awesome success and see all the interesting things you're doing. And thankfully, I get to come back once in a while, say hello, and talk a little bit. So today, I'd like to talk about the art of code churn. It's not a very kind of familiar term, like a very technical, like scientific term, but I think a lot of us as developers and programmers know what that means. So who am I? I'm Erik Frederiksen. I've got a handy Twitter account here, and it's pretty easy to find me online, but I've been at Noodle Cake for over 4 years now. And we've been developing some, games. We've done some health scheduling software. We've done all sorts of stuff over those 4 years. And one obstacle that we run into again and again, over and over and over again, is code churn. That's basically regressions popping up as a result of us adding new things. So we're constantly working on our code bases. We refactor things, we fix bugs, we add new features, we upgrade various libraries. Sometimes there's new features out of those libraries we want, there's security concerns. And then all of a sudden our old code doesn't work anymore. And well, that's no good, because we spent all that time writing it. So what can we do to keep the code that we've written solid, stable, and functional? So there's a couple of ways we've gone about it. We write a lot of tests. Do we do more manual QA? Do we add extra procedures and processes, more code reviews and pull request reviews? Do we rewrite everything in a super, super tight language like Ada, where nothing gets past the compiler? So this is just kind of an illustration of, the average code base that I feel like I've dealt with. So one of our longest running projects is a healthcare I always end up saying health scare, healthcare scheduling project that's been living for over 5 years now. And it starts off great. It's like a nicely new purchased set of Christmas lights that you picked up at Canadian Tire. Pull them all out, the lights are straight, sit on the wall and look great. Year 3, hell, like some projects it's, month 3, day 3. It quickly turns into this kind of thing. I think we've all got one of these in the basement of our parents' house, where nobody even wants to deal with it anymore, so it just gets thrown out. And year 5, we end up looking a bit like this guy. And you can't actually see it in the whole picture, but this man is literally drowning at Christmas lights. It's horrifying. It's really, really sad. So the biggest obstacle that we've always dealt with in our long-running projects is our code churn, and also known as technical debt. There's some other names for it. But there's an extra participant in every meeting that we do that sits at the table when we're doing sprint planning, and that's the code we already wrote. So it's great that we have this code. It does a lot of things for us, but it does also limit our options. It keeps us from being as agile as we want to be. And it's always something we have to consider. And in my mind, the root cause of that is the complexity that we've added to the system. So there's inherent complexity, which means it's not our fault. Kind of came along with either the problem domain, or it just kind of came along with the tools and the services we're using. But most of it's the complexity we created. So I talked about who I am now, but an interesting question I think is, who was I last year? Same guy mostly. I had about a year less experience as a programmer. I didn't understand the problem domains we were working in as well as I do now. But I was much closer to the problems I was solving, and I knew exactly what my solutions were supposed to do and how they were supposed to work. But I don't think I understand that stuff nearly as well as I used to. I look back at my old code, and it doesn't make nearly as much sense, and there's a lot of me getting quite righteously angry at my former self. And I'm still writing code these days, but who am I going to be a year from now, and what does that look like? So this slide is pilfered entirely from Rich Hickey and some great talks he's done on the nature of simplicity. But basically, we can only hope to make reliable those things we can understand. There's a great quote, I think it was from Dennis Ritchie, that says, to write a piece of code, you must be so smart, but you must be twice as smart as that to be able to debug it. So if you write code as clever as you can possibly be, like by definition, you can't fix it or debug it. So we can only consider a few things at a time, and when we start tangling things together, when we intertwine them, make them complex, we have to consider them together. We can't analyze them individually anymore. And in my mind, this is where the root of all of our complexity and our code churn problems come from. We end up taking the Christmas lights out of the box every year, putting it back in a different way, take it out again, put it back, until we have this tangled ball of lights. And sure, it's going to be more difficult every year as we add more lights to the chain to put it back in the box neatly, but there are things we can do to kind of help ourselves out here. So getting back to kind of some definitions, the root of some of these words. The word simple, taken at its root, is a single fold or a braid. So it's a single operation when dealing with like ropes. So a single concern, a single idea that's understandable as one component. And complex refers to things being braided together. So several ropes or several strings all braided together. So you can't understand one part of this thing without looking at the whole thing. There's too many interrelated parts. And then we talk about things being easy and hard. Ease at its root means familiar, close at hand. So similar to things that we already know, and things that are hard are the opposite of that. They're far away from what we know and where we are right now. And one thing to note too is that easiness is subjective and relative. So things like speaking Mandarin may be easy for some people and hard for others just by virtue of the fact that they grew up in a certain place. It's totally subjective. There's no objective way you can say that something is easy or hard. And which kind of raises the question, right now in our industry, are we favoring solutions that are simple and easy to understand? Or are we are we favoring solutions that are easy? They're just close to what we know. So I think a great study in this is qmail. Dan Bernstein is one of the smartest guys out there, and I thought it was kind of interesting looking at, this is the diagram for how qmail works. So sort of left to right, mail comes in, mail gets processed, mail goes out. The whole point of doing this in this way is DJB saw how other mail programs, particularly SendMail, were written. They ran entirely as root, they were hideously complex, and they had massive security vulnerabilities. So this system, while it may look complex on the face of it, each one of these processes actually has one function. And for one of them, it runs as root, and its only job is to bind to the necessary ports that you need root access for. It doesn't do anything else. It uses pipes to communicate with anything else. So there's actually very few ways to get root access through an exploit on this. It's actually very simple in the fact that each one of these processes, you could isolate that, and based on what your inputs were supposed to be and what your outputs were supposed to be, you could write that system independent of anything else. You could parallelize this development and nobody would actually have to meet, theoretically. Doesn't always work that way. So it kind of raises the question, is this a simple solution? Is this an easy solution? It's not really easy. It's not how we write a lot of services, but I think it is simple. And is this complex? Does it have more moving parts than it needs to? And are things more interrelated than they need to be? Well, I don't think so. I think it's actually a pretty good example of that. But I'd say it is actually hard. It is a lot different, I think, from a lot of the conventional kind of things that we look at. So some examples of things that we're doing right now to fight this code churn, to fight our regressions. A lot of static analysis where we can. Our tools don't help out with that, and I'll go into that a little bit. We do a lot of unit testing, a lot of acceptance tests, and a lot of QA. There's sort of no way around that. That's once the rubber hits the road, you sort of need to do that kind of testing. But what can we do to make these processes easier? Are we using the right tools? Are we doing a whole bunch of work that we just don't need to? So some of the things that we found have helped us big time in reducing the complexity of our systems and making them easier to reason about and understand. So using, hitting the books from school and going back to finite state machines. This is a pattern we use over and over and over again. Most database records have some sort of state attached to them and a full FSM, declarative FSM of how they can change and act and interact. Things like streams, iterators, and pipes. The Python itertools modules do a really nice job of being able to look at a data set in sort of an immutable sort of way. Mailboxes and queues for distributed computing. Fantastic stuff. It sure beats the days of using pthreads for anything, trying to lock mutexes. Yeah, can't handle that. Parser generators. Anytime anything needs to be parsed, if it's beyond a regex, and it usually is, it goes into a parser. Same with pure functions and immutable data structures. This is kind of old news for a lot of the functional programming guys, but I think it's worth looking into in our kind of procedural imperative languages too. And one thing I look for in tools as well is tools that scale in difficulty in sort of a linear kind of manner. A great example I've seen, and one that we frequently run into, is the Django object relational mapper. Easy things are really easy, like so easy. But when you start asking some different difficult questions, and things that I know a database can do, group bys and aggregates and that sort of thing, it gets difficult really fast, to the point of anything sort of looking like a report that you're going to write quickly becomes like either raw SQL or you just want to throw your laptop out the window. SQL Alchemy, I think, does a lot better job of that. Easy things are easy, and it scales pretty much up to, like, if you want to do very, very difficult things, you can do them. It's not going to be easy, but you asked it to do something difficult, and I think that's okay. I'm just going to, how we doing? Okay, anyway. So I don't have a timer on this one because I actually don't know how to set that up. That's how much public speaking I do. Basically, the other thing I'm looking for too in the tools that we use these days are things that are solving the hard problems. The hard problems I see these days are multi-core CPU utilization, distributed computing, huge problem. Maintaining thousands of connections at once with WebSockets or HTTP2, and then code churn and long-lived code bases. And I wonder if our current tools are actually doing a good job of handling these things. And I'm always looking for new ones that I think can help us. Semi-related. And how open source works these days. But anyway, I guess the long and the short of it is build simple things. If you find yourself getting clever and find yourself writing something that you don't think you're going to be able to understand in 1 month, 6 months, 2 years from now, it's probably worth taking a step back and working with somebody else on it and seeing if you can come up with a simpler solution. Thanks very much.